So we're going to talk about solving and graphing inequalities. Before I get too far into it, I want to go over a few basics to make sure we understand everything as needed. So if we look at the first expression right here, we would see that x is less than 3. This doesn't say greater, it says less, because we read from left to right. So it's less than 3. Over here it says y is greater than or equal to, that's what the line underneath means, greater than or equal to negative 3. Okay, now the important thing to know here is how I would actually graph that. What you need to remember is that anytime you have one of these where it is not underlined, anytime you have just less than or just greater than, you have an open circle. Anytime you have something where it is or equal to, like greater than or equal to, less than or equal to, you actually put a filled in circle. And that'll make sense in just a second. Let's first try plotting x is less than 3 and y is greater than or equal to negative 3. So let's pick the point right here in the middle of my number line and call it 0. So there's my 0 right there, okay? Everything to the right are my positive numbers. Everything to the left are my negative numbers, right? Good. Now, I've got x is less than 3. So if I were to do this, I would say 1, 2, 3 spots. I know it goes there. What I said before was an open circle. That makes sense because what I'm saying is put an open circle around the number 3. Now, the best way to remember this is that if my variable is over here on the left, like this, x is less than 3, my arrow for my line would be like this, pointing in that direction. So x is less than 3. I would put an open circle and then an arrow pointing to the left. And think about what that means. Less than 3. Would 2 or 1 be less than 3? You should say yes. 1 is less than 3, 2 is less than 3, 0 is less than 3. Are those all to the left of that open circle? They are, and that's why that arrow is now pointing to the left. It's saying any number to the left of that open circle. Now, let's try doing our y is greater than or equal to negative 3. So I would first hop 1, 2, 3 spaces to the left. And like I was saying before, you're going to put a closed circle on that number. Closed circle right there. Now, as I said in the last one, I said that anytime we have our variable on the left of our expression, meaning y is on the left of greater than or equal to negative 3, that tells us what direction our arrow is even pointing in. So we'd say a closed circle, and then an arrow pointing to the right. Now think about what that means. Any number greater than negative 3 is what y can be. Meaning, could 0 be greater than negative 3? You should all tell me, yes, 0 is greater than negative 3. Negative 1 is greater than negative 3. If I look at where negative 3 was on this number line, which is right there, correct? Any number to the right of it, like that, would be a greater number than negative 3. So now I've got two expressions here that make sense. On the left, we have 3 is less than 5. Well, that's true. 3 is less than 5. We also have on the right, 6 is greater than 2. Again, that's a true statement. Okay, the reason I showed you that is because before I get with anything with variables, I want you to see with numbers a trick. Let's say I have 3 is less than 5 on the left. Now, what if I want to multiply both those numbers by 2? I would say 3 times 2 and 5 times 2. Well, what's 3 times 2? 6. And let's do 5 times 2, 10. Is 6 less than 10? Yes, that is a true statement. 6 is less than 10. But now, what happens if I multiply by negative numbers? So let's look on the right. If I have 6 is greater than 2, let's say I multiplied times negative 2 to both of them. Okay, because I have to do the same thing to both sides. What is 6 times negative 2? Negative 12. What's 2 times negative 2? Negative 4. Okay, now you're about to say, oh, you just put that sign down there, right? But let's think about that for a second. If I put the greater than sign, if I said negative 12 is greater than negative 4, is that true? No. Think about what you know about negatives. The further away the number is from 0, actually the lesser the value is. So negative 12 is less than negative 4. Negative 4 is actually greater than negative 12, isn't it? So that number actually turned around, meaning anytime you multiply or divide with a negative number, you need to turn around the sign of your inequality. Now, that's not the same thing like right here. I multiplied with a positive. We kept the sign the same direction. Over here, I multiplied with a negative. I had to turn the sign around, and I just showed you with numbers why that's a true statement. So I'm going to apply that again, but now with a variable. If I look here, I have 2x is less than 10. I don't want to know what 2x's are. I want to know just x. So I need to divide by 2 because 2x divided by 2 will get x all by itself. I divide both sides by positive 2, therefore my sign will stay the same direction. I get x is less than 5. Okay, now I've got negative 2x is greater than 10. Now, negative 2x means negative 2 times x, so to get rid of that negative 2, I divide by negative 2, and I'm going to do the same thing to both sides. But what just happened there? I divided by a negative, so that sign, when I bring it down, needs to turn around, meaning it should say x is less than negative 5. Now let's think about that for a second, and let's make sure that makes sense. So, on the left, if I said x is less than 5, if I plug that in and I say 2, and then give me a number less than 5, let's say 4. Is 2 times 4 less than 10? Well, let's see. 8 is less than 10, right? Let's go back over here on the right and try that. Let's pick a number that is less than negative 5. So let's say negative 2 times a number less than negative 5. Let's say negative 6. My original expression had the sign facing to the right, so greater than 10. So if I'm just plugging in a number negative 6 into my original expression up here is all I'm doing. So let's keep it going. Negative 2 times negative 6. Now negative times a negative is a positive. So 2 times 6 is 12. Greater than 10. Is 12 greater than 10? Yes. Now if I hadn't turned that sign around, it actually would have said 12 is less than 10, which doesn't make any sense. So let's go ahead and graph that. And if we say this right in the middle is 0, anything to the right is positive, anything to the left is negative. Okay, so the one on the left was x is less than 5. So I would go 1, 2, 3, 4, 5 spaces. Whew, good thing I had enough. I would then do was it an open or closed circle? Does anybody remember? If it is not or equal to, meaning it does not have that line underneath, which it does not, we actually have an open circle. We then, I'm sorry that didn't connect properly, but we have an open circle. And which way is the arrow pointing? Like I said, if it's to the left of it, if the variable's on the left, that arrow is actually pointing for us to the left. And think about that. X is less than 5. Does that mean that any number less than 5 would work? So like, let's pick 2. Is 2 less than 5? Yeah, and that's to the left on the number line of 5. Now let's also do our one on the right, which was x is less than negative 5. So I'd say 1, 2, 3, 4, 5. Now, again, is that an open or a closed circle? Should say open. Okay. Now, x is to the left. So again, we point to the left with our arrow. And I'm sorry I ran out of space, but let's think about that. Meaning, pick a number. Negative 7. Negative 7 is less than negative 5. If we're looking at a number line, isn't that to the left of negative 5? So, that makes sense. So let's try solving and graphing this simple inequality. So I have 6 minus x is greater than 3. I want to get x all by itself. This 6 over here is positive. So to get rid of it, I need to actually subtract it. I don't care about what it says right here. That is subtract 6, correct? The sign to the left stays with that number. So this 6, I need to subtract. In order to subtract, I need to do the same thing to both sides. Now what's left over here, bring this down, I have negative x greater than, what's 3 minus 6? Negative 3. Now, a bunch of you are going to say, well, how come you didn't turn the sign? Because we did not add or subtract. I'm sorry. We added or subtract with negatives does not change the sign. It's only when we multiply or divide. So that stays the same direction. Now I have negative x is greater than negative 3. But the catch is I don't want to know what negative x is. I don't want to know what the opposite of x is. I want to know what x is. So to get x by itself, if I have a negative times a negative, is that a positive? Meaning if I took negative x and multiplied it by negative 1, would that turn it into positive x? It would. So negative 1 times negative x is positive x. Negative 3 times negative 1 is positive 3. What happened to that sign now because I multiplied with a negative? So we would have x is less than 3. So let's try to graph that. Let's call this right here our 0. Let's go find positive 3. 1, 2, 3 spaces. Now, is that open or closed circle? Open. Now, which way should the arrow point? And just think about any number. Pick a number less than 3. Is it to the left of 3 on a number line? Yes. So let's do another one here. I have negative 2m plus 4 is less than or equal to 34. Okay, first step in getting my m's all by itself is I want to get rid of this 4. If this says plus 4, to do the opposite, I would subtract 4. Got to subtract 4 from both sides. That leaves me with negative 2m less than or equal to 30 minus 4 is not 15, not 16. Oh, yeah, 30. Got it. Sorry. Now, I've got negative 2 times m is less than or equal to 30. I want m all by itself. That is negative 2 times m. So to get rid of it, I divide by negative 2. I divide both sides by negative 2. That leaves me with m, and 30 divided by negative 2 is negative 15. But uh-oh, what happened? I just divided with a negative. So that whole sign, what happens to it down here? Should be rewritten as greater than or equal to negative 15. Now, let's go ahead and plot that. Is that an open or closed circle? It's closed, meaning it's filled in. Now, in this case, on my number line, I'm not going to go ahead and start at 0. I'm going to start at, say, negative 15. How great for me. So if this is negative 15 right here, okay? Like I said before, we agreed that it was a closed circle. So we close it in. That's my best attempt at closing it in. All right, which direction is that arrow pointing? So m is greater than or equal to negative 15. And think about that. Let's say it was negative 10. Is negative 10 greater than negative 15? Yeah. Is that also to the right on the number line? You should say yes. I really quickly wanted to just take a moment to say why we have those open and closed circles. So look at x is less than 2. And let's say if we were to put that on the number line and call this 0, that'd be 1, 2, 3, 4, and 5, right? That's 4, that's 5. Yeah, you got the idea. Okay, think about less than 2. Could that be 1? Yes. Could it be 1.5? Yeah. Could it be 1.999999999 forever repeating? Yes. Could it get really, really, really stinking close to 2 but never actually be 2? Yes. But what about y is greater than or equal to 3? Does that mean it could be any number greater than 3, like 4, 5, 6, 7, 8, 9, infinity? Yes. Could it also be 3 itself? Yes. So that way you can actually include 3 with it. So when I'm going to circle those numbers, I can get with x is less than 2. X is less than 2, meaning it can get really, really stinking close to 2, but it can't actually be 2. So I can have that circle all the way around it as much as you want, but I could never actually include it. And so there I've got that, not touching it because I can't actually use it. Now for greater than or equal to 3, I can go around it. I can take any number greater than 3, but because I can also have 3, I'm going to touch 3 because I'm saying, you know what, I can take 3 with me, and I can go that way.